Hi everyone, so we meet again in Chapter 4, Applications of Differentiation. 4.2 Extremum Problems. Below are the learning outcomes for 4.2. First, find the stationary points. Then, identify minimum and maximum points by using the first and second derivative test. And solve optimization problems. Before we proceed, let's take a look at quick view definition. First, we have stationary point, which a point on a curve where the slope is 0. This can be where the curve reaches a minimum or maximum. While maximum point is a high point and minimum point is a low point. And stationary point consists of maximum point and minimum point. Let's take a look at how to find the stationary points. The stationary points of y equals to fx can be found by steps below. First, differentiate the equations of the curve y prime. Secondly, find stationary value x equals to c where y prime equals to 0. And thirdly, find stationary point by substitute x equals to c into y. Let's start with example 1. Find the stationary point for y equals to 1 over 2x squared plus 4x minus 16. Okay, first we need to find dy dx equals to x plus 4. From this, dy dx, we equate it with 0, so we will have x equals to negative 4. Alright, so then we substitute x equals to negative 4 into y. So we will have y equals to 1 over 2 times negative 4 squared plus 4 times negative 4 minus 16. Then we will have negative 24. So negative 4, negative 24 is stationary point. Example 2, find the stationary points for y equals to x cubed minus 3x squared plus 6. So we will start with difference y. So we will have 3x squared minus 6x. Then we take this value, 3x squared minus 6x equate with 0. We factor this out, we have 3x. And left here is x minus 2 equals to 0. So we will have x equals to 0 and x equals to 2. Okay, then we take this x equals to 0 first. We substitute into y. Then we will have 0 cubed minus 3 times 0 squared plus 6, which imply 6. Secondly, we substitute x equals to 2 into y. We will have 2 cubed minus 3 times 2 squared plus 6, which imply 2. Then, stationary points are 0, 6 and 2, 2 are stationary points. How to identify minimum and maximum points? Extremum point of y equals to fx can be found by steps below. First, differentiate the equations of the curve y prime equals to f prime. Second, find the stationary value x equals to c where y prime or f prime c equals to 0. Third, find the stationary point by substitute x equals to c into y equals to fx. Fourth, test the type of the stationary point is either minimum or maximum by either first derivative test or second derivative test. We also must list the interval where a functions increase or decrease if the questions asks. First derivative test. How to get relative maximum point? First, we must create the table and find dy dx equals to 0. Secondly, how to find relative minimum point? Also must create table and find where dy dx equals to 0. Let's take a look at the steps. Example 3. Find the extremum points for y equals to x cubed minus 3x squared plus 6 by using first derivative test. This question is actually similar to previous questions, but we try to do it again. So first thing first, we must find the dy dx, which is 3x squared minus 6x. And after that, we take this 3x squared minus 6x equals to 0. Factor this out. 3x minus 2 equals to 0. Then we will have x equals to 0 and x equals to 2. Then we substitute x equals to 0 to get y. So 0 cubed minus 3 times 0 squared plus 6. So we will have 6. Secondly, we substitute x equals to 2 into y. 2 cubed minus 3 times 2 squared plus 6. It implies 2. That means 0, 6 and 2, 2 are stationary points. Okay, from these stationary points, we want to find what types of 0, 6 and 2, 2 is either maximum or minimum. Okay, since we have two values, first we try to draw a number line. Okay, we have 0 and 2. So from here, we draw our table. Okay. And then another 3 row. Okay, so this is test value, while this one is dy dx. Okay, and then here is shape. Okay, here is negative infinity to 0, while this one is 0 to 2, and here is 2 to infinity. Okay, so we choose the test value. How about we choose negative 1 here, and here is 1, while here is 3. So we substitute this value into our dy dx, which our dy dx is 3x squared minus 6x. So we substitute negative 1 into dy dx, we will have a positive sign, while we substitute 1, we will have negative, and we substitute 3, we will have positive. Okay, what is the shape for positive? It's actually a straight line go to the up, while negative is a straight line go to the below, and positive also like this. So what happened here is, okay, it's come from a positive line, then go to negative line. So what happened here is maximum, while what happened here is minimum. So take the value, okay, up here. So 0 together with the point 0, 6 is maximum point. Okay, while minimum refer to the value here, which is 2, together with the point which is 2, 2 is minimum point. Okay, next questions which is asked, hence state where the functions is increasing or decreasing if any. Okay, based on the table that we construct previous slide, we find out that y equals to x cubed minus 3x squared plus 6 is increasing at interval negative infinity to 0 and 2 to infinity. This is based on the positive line in the table. And y equals to x cubed minus 3x squared plus 6 is decreasing at interval 0 to, this is referred to the negative line in the table. Example 3b, find and determine the type of stationary points of fx equals to 4x plus 9 over x by using first derivative test. Okay, firstly, we must difference fx. So we will have f prime x equals to 4 minus 9 over x squared. So from here, we take 4 minus 9 over x squared, equate it with 0, and multiply everything with x squared. We will have 4x squared minus 9 equals to 0, and then we will have 2x minus 3 and 2x plus 3 equals to 0. So x equals to 3 over 2 and x equals to negative 3 over 2. Okay, by using x equals to 3 over 2, we substitute into y. So we will have f3 over 2 equals to 4 times 3 over 2 plus 9 over 3 over 2, which imply 12. Okay, so then we substitute x equals to negative 3 over 2. Then substitute into f 4 times negative 3 over 2 plus 9 over negative 3 over 2. We will have negative 12. Then we make a conclusion here. 3 over 2, 12. Okay, and negative 3 over 2, negative 12 are stationary points. So let's construct the table, but bear in mind x cannot equals to 0 since we have a rational. So we start with draw the number line. So we have negative 3 over 2 and 3 over 2. Let's move on to the table. Okay. So we add on another 3 row. Okay, here is negative infinity to negative 3 over 2, while here is negative 3 over 2 to 3 over 2, and here is 3 over 2 to infinity. Okay, so here is test value. Okay, while here is dy dx, and here is shape. Okay, so our dy dx is 4 minus 9 over x squared. Okay, so we choose our test value. The first one is, why don't we try negative 3? Okay, and here is we choose 1, and here we choose 3. So we substitute negative 3 into dy dx. So we will have positive. Next we have negative, and next we have positive. So here will be a straight line to the up. Here is negative straight line, here is positive straight line. So what happened here is maximum. What happened here is minimum. So maximum, we refer to negative 3 over 2, which negative 3 over 2 and its point, which is negative 12, is maximum point. Okay, while minimum refer to 3 over 2, which is the point is 3 over 2, 12 is minimum point. Hence, state where the function is increasing or decreasing, if any. So we find out that based on the graph, there's a positive line. So fx equals to 4x plus 9 over x is increasing at interval negative infinity to negative 3 over 2 and 3 over 2 to infinity. Fx also is decreasing at interval negative 3 over 2 to 3 over 2 based on the negative line in the table. By second derivative test, for relative maximum point, if second derivative less than 0, when x equals to c, then the point is relative maximum point. When relative minimum point, if second derivative greater than 0, when x equals to c, then the point is a relative minimum point. Example 4a, find the extremum points for y equals to x cubed minus 3x squared plus 6 by using second derivative test. This is again similar to previous lesson. Okay, we just want to make sure either the answer is the same, even though if we use second derivative test. So we start with difference dy dx equals to 3x squared minus 6x. Okay, then we take this 3x squared minus 6x equals to 0. Factor this out, 3x, x minus 2 equals to 0. Then we have x equals to 0 and x equals to 2. Okay, we substitute x equals to 0 into y. So we will have 0 cubed minus 3 times 0 squared plus 6. So answer is 6. Okay, then we have substitute x equals to 2 into y. And we will have 2 cubed minus 3 times 2 squared plus 6. And then we will have 2. So make a conclusion, 0, 6 and 2, 2 are stationary points. How to use second derivative test? First, we must have second derivative, which 6x minus 6. Then we use our critical value, substitute x equals to 0 into second derivative. So we will have 6 times 0 minus 6, which implies negative 6. Negative 6 is less than 0. So if our second derivative less than 0, that means it is a maximum point. Okay, secondly, we substitute x equals to 2. Okay, so into our second derivative, so we will have 12 minus 6 is 6, which is 6 is greater than 0. So if our second derivative is greater than 0, so it is actually a minimum. So we make a conclusion where 0, 6 is maximum point. Okay, and 2, 2 is minimum point. Example 4b. So again, we have the same questions as previous. So we directly different this. Okay, dy dx imply 4 minus 9 over x squared. Okay, we equate 4 minus 9 over x squared with 0. We multiply everything with x squared. So for x squared minus 9 equals to 0. Factor this out to x minus 3. To x plus 3 equals to 0. So x equals to 3 over 2 and x equals to negative 3 over 2. Then we substitute x equals to 3 over 2 into fx. 4 times 3 over 2 plus 9 over 3 over 2, which imply 12. Okay, next we substitute x equals to negative 3 over 2 into f. Okay, we must write down everything. Okay, this implies negative 12. So we make a conclusion 3 over 2, 12. Okay, and negative 3 over 2, negative 12 are stationary points. Okay, next to use second derivative test, we must find the second derivative. Okay, so we will have 18 over x cubed. Okay, then we substitute our stationary value. First is x equals to 3 over 2 into second derivative 18 over 3 over 2 cubed. So answer is 5.333, which greater than 0. That means it is a minimum. Then we substitute x equals to negative 3 over 2 into second derivative. Okay. Alright, so we will have negative 5.333, which is less than 0. Okay, so that means it is a maximum. So we bring together the point, which is first 3 over 2, 12 is minimum point. Okay, while 3 over 2, negative 12 is maximum point. So please try this exercise and refer to the answer. Okay, for questions, test yourself. Find the local extremum for y equals to 4e to the power of 4x plus 9e to the power of negative 4x. Okay, first we need to differentiate. We will have 16e power 4x minus 36e power negative 4x. Then we let it equals to 0. So we try to solve the exponential equation. We will have x equals to 1 over 8 ln 9 over 4. Then we take this value, substitute into y. Okay, just press our calculator. We will have 0.1014. So we make a conclusion. Stationary point is 1 over 8 ln 9 over 4, 0.1014. Then we use the second derivative test. We differentiate. We will have 64e power 4x plus 144e power negative 4x. Then we take x equals to 1 over 8 ln 9 over 4, substitute into second derivative. So we will have 192. Just using calculator, 192 is greater than 0. So we can conclude that it is a minimum. So make a conclusion, 1 over 8 ln 9 over 4, 0.1014 is a minimum point. So that's mean we finish with 4.2. We're going to continue with next video with 4.3.